Hello and welcome to the solutions of NEST 2019 session 1 mathematics. So we move on to the first question. Well, this is a pretty simple one. If x and y are positive real numbers such that x, and this is the I'll take mouse, greatest integer of x, and that is y, and the greatest integer y is equal to 71, then x plus y equals. So in this case, I'll just choose a pen. So in this case, how we go about? Well, if x and greatest integer of x is 36, I just took x squared is equal to 36, which gives x is equal to 6. If you substitute 6 over here, then if you also substitute 6 over here, because the greatest integer of 6 is nothing but 6, so 6 into 6 becomes 36. In case of y, this is a little tricky. Again, I'll do this thing, y squared is equal to 71, and then the root of 71, which gives us 8.42. Now, the greatest integer of 8.42 is nothing but 8. So what is y? Y is nothing but 78, 71 by 8. So x plus y is equal to 6 plus 71 by 8, that is 119 by 8. 4 sin A is equal to secant B and 3 tan A is equal to tan B. Well, in such, and it is asked right angle, equilateral, isosceles or obtuse angle. In such cases, we must look for the sum of angles. So if I write 4 sin A is equal to secant B, it becomes sin A cos B is equal to 1 by 4. And by the second condition, it is 3 tan A is equal to secant B. So, 3 tan A is equal to tan B. In such a case, if you expand, you will get sin A cos B over here, and you get cos A sin B over here. So, when these two comes in, we know the formula sin of A plus B is equal to sin A cos B plus cos A sin B. So, substituting that, we get answer as 1, therefore A plus B is equal to 90, therefore it's a right angle triangle. Third one. A six-face unmatched dice is thrown until a number greater than 4 appears. Okay, so he's asking the probability that this occurs on the nth throw, where n is even. So when n is even, the first case is n is equal to 0, not a bother. So the second case is n is equal to 2. So when n is equal to 2, so the first case would be less than 4, over here less than 4, and then the second throw would be greater than 4. We get it in 2 throws. If you want it in 4 throws or 4 throws, then less than 4, it happens 3 times, and the fourth time is a number greater than 4. And similarly, it goes to an infinite GP. The formula of infinite GP is A by 1 minus R, where the common ratio in this case is 4 by 6 whole square. And this is the first term, which gives us 2 by 5. The tangents at the extremes of the lattice rectum of the parabola are, that's a property, the lattice rectum meets minus a comma 0. In this case, f of x is this. So we are asked the 4 options. Well, in such cases, that is strictly increasing, decreasing, so we need to find the derivative of it. So f dash of x I find out as this, and you have to equate it to 0. Well, this cannot be 0, this cannot be 0, so this can be 0, and the roots are minus 1 plus or minus root 5 by 2. So we'll make a number line, simple, and then write negative, positive, and negative, as we always do. Means over here it is a decreasing function, over here it's an increasing function, and then it's a decreasing function. Well, let's ask, f of x is strictly decreasing on 0 to infinity. It is no, so this is the wrong option. It's a surjective function. Surjective function means it should have the image in real number r. Well, this can be positive. This f of x can be positive easily, but can it be negative? Suppose I take x equal to a negative number, say minus 5 or a minus. So over here, if we substitute a minus 5, then e to the power minus 5 divided by 1 plus minus of 5. Well, in this case, as you can see, the numerator and denominator cancel each other, the negative signs, and therefore the number is always a positive number, and hence we cannot get a negative number, so this is not an option. Strictly increasing function from 0 to infinity, again, no. So the fourth option is the correct option. If you want to verify, you can do a double derivative and check. or you can check from here itself that if it is decreasing, increasing and decreasing, so in this range what would it be, because over here there is a sign change, and you can verify, but no need to do that. In such cases, in such questions where the argument of z minus z is asked, it is a circle. This thing provides, it's a circle with the radius 1 and origin 1 comma 0. So I'll quickly draw a circle. This is 1 comma 0 is the origin, and the z it's given that argument is pi by 6. So this is at the z is at 30 degrees from the origin. So this is my z. Then what would z minus 1 be? It would be a line through the center of the circle. Well, if this is 30, this is 60 by double angle theorem, that if a chord makes an angle at the perimeter makes double the angle at the center. That the basic formula in 10th class. So we have asked argument of z square minus z. So I can write as argument of z into z minus 1. I can write as argument of z plus z minus 1. And argument of z is nothing but 30. And argument of z minus 1 nothing but 60. So 30 plus 60 is bingo, 90. A variable line passes through a fixed point and cuts the coordinate axis at a comma b. Okay, so in such cases, this is fixed. So the line can be this, or it can be this, or it can be this. This would be the fixed point, and this would be the intercept. So you asked that this the midpoint of each will be, what will be the equation of that. In such cases, I've chosen the fixed point to be alpha beta, and m be the slope, which is a variable. This is a constant, this is a variable, and the equation becomes y minus b is equal to m times x minus alpha. So the midpoint would be alpha minus beta by m comma 0, and b 0 comma beta minus alpha m. How did I find that? By substituting y is equal to 0 or x is equal to 0 in subsequent cases to find a and b, which it will cut the coordinate axis. The point will cut this point, and this point I find out, that is a and b, or the vice versa. I think yeah, a is this is a and this is b. So the midpoint would be by the midpoint theorem we found out this. Okay, so when x is this, y is this, so somehow I have to eliminate this m and find the equation in terms of x, y, alpha, beta. So how did I do that? I just did multiplication of the numbers. See, x is this, y is this. So I did x minus of alpha by 2 multiplied by y minus beta by 2. If you multiply, you'll get minus beta by 2m multiplied by minus alpha by 2m. The m gets cancelled, and we get alpha beta by 4, which is the equation of a hyperbola. Hence, hyperbola is the answer. The positive integer k is perfect if the sum of its positive divisors equals to k. If n is a perfect number, then the sum of reciprocals of its positive divisors are. In such cases, it's normally advised to take a number, any choice. So by elimination, I found if k is equal to 6, the divisors are 1, 2, 3, and 6, which was 6 plus 3, 9, 10, 11, 12. So it is 2 into k. So the reciprocal of them is 2. Simple, easy peasy. The y-intercept of three parallel lines, 2, 3, 4. So y-intercept is given, and the sum of the x-intercepts is given. The slope of these three parallel, as is parallel, so the slope will be equal. So slope is equal to minus y by x. We all know how, y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1, then we get it as minus y by x. So similarly, if the y-intercept is given as 2, 3, 4, I just substitute 2, 3, 4, that is x1, x2, x3, all equal to k. We are given x1 plus x2 plus x3 as 36, it is already given. So substitute them, and I got k is equal to minus 4, that is my slope. This we are asked the maximum of 1 minus x comma 1 plus x comma 2. So what do we do? Y is equal to 1 minus x, y is equal to 1 plus x, and y is equal to x. We draw three lines, this, and this. So we are asked the maximum. So maximum would be this, and this. This would be a maximum. Sorry for the not the straight lines. So we are asked f is strictly increasing in the interval 1 to infinity. Here 1 to infinity, yes, it is increasing. So this is a correct question, correct option. F is continuous everywhere. Yeah, there are no breaking points or anything, so it is continuous. This full straight line, so this is correct. Differentiate everywhere? No. At this point and this point, it is not differentiable. So this is wrong. And the minimum value of f is attained only at finite points. No, it's attained at infinite points from -1 to 1. So this option is also wrong. It's a matrix, 2 by 2 matrix with real entries, and let sk with the sum of diagonal entries, that is nothing but the trace, and p to the power k. So it is p to the power k. This is a very tricky question. I'll tell you how to go about it. So first option we'll look is P is a singular matrix if the trace is 0. So it is a 2 by 2 matrix, as I said, so I've taken P is equal to A, B, C, D. Now the trace S1 is 0. S1 is 0, why? Because this is P to the power 1, so S1 is 0. Therefore A plus D is 0, therefore A is equal to minus D, or D is equal to minus A. So I substitute A, B, C, and minus A. So now the determinant of this is nothing but minus A square minus BC, so this is our determinant. Why is it required? I'll tell you later. Now I'll take S2 is also equal to 0 because k greater than or equal to 1 it's asked. So that is p square, and p square is nothing but a square plus bc, 0, 0, a square plus bc. This is normal, this simple substitution. So not substitution, multiplication, taking this matrix into consideration. So this is nothing but minus of delta p into I, determinant of p into I. So that is why this determinant of p is required from here. Now, so I have written that S2 is a trace of p square. So what is trace of this is nothing but minus 2 into det of p. If S2 is 0, now it's said that S2 has to be 0. Therefore, this term has to be 0. If delta p is equal to 0, determinant of p is equal to 0, therefore p is a singular matrix. Now, S2 to the power m is greater than 0, m is greater than or equal to 2, and S1 is 0, which is already given over here. So we have to say that P is non-singular matrix. So S1 is equal to 0. I'll take this one. S1 is equal to 0. So this we already got from here. S1 is equal to 0. So trace of S2 to the power m, that is trace of P squared to the power m. Yeah. So can I write it as trace of P squared to the power 2 to the power m minus 1? Now what is P squared? P squared we already find out. That is delta P into I. This term. So I written delta P into I to the power 2 to the power minus 1. So can I write it as this? And therefore trace of I is a 2 by 2 matrix, so trace of I is nothing but 2. So 2 into this is always greater than or equal to 0, provided P is not equal to 0. Therefore it is a non-singular matrix. So this is the correct answer. S 2019 and S1 is again 0, so we take the second option into consideration, and trace of P to the power 2019 I can have as p square to the power 1009 multiplied by a p. Okay, then p square again minus p into I, which is to the power 1009. That's nothing but minus p to the power 1009. I to the power 1009 is nothing but I itself. So over here I multiplied by p is nothing but p, and this is a constant term, so I'll take it outside. And trace of p is what is trace of p? P is nothing but a, b, c, and minus a. The trace becomes 0, and hence this is the correct option. So in the fourth option, it says that there's a matrix U such that PQ minus QP is equal to I. So well, if two matrices are equal, the traces must be equal. So I have taken the trace of this is equal to trace of this. So trace of this is nothing but trace of PQ minus trace of QP, and trace of PQ minus trace of QP. Well, no, trace of AB is same as trace of BA. So therefore, this gets cancelled, and 0 is equal to 2 is the wrong option. Therefore, this is the wrong option. Question number 13. F maps from 0 to 1 to 0 to 1. It's a constant continuous function different from the identity function. So f is not an identity function. What is identity function? Which means that f of o is not equal to 0 and f of 1 is not equal to 1. This is said, this is not an identity function. Then we'll come back to the then later. So again, I've written over here, it's not an identity function, and hence it is this. Now, in such cases, in such cases, we need to say the line y is equal to x. So we'll take a function g of x such that f of x minus x. Okay, because y is equal to f of x, that is common sense. So we'll find g of 0, that is f of 0, and we find g of 1, that is f of 1 minus x. Now the function maps from 0 to 1 to 0 to 1. So f of 0 must be obviously greater than 0, that is positive, and f of 1 has to be obviously less than 0, that is negative. So now if two functions, one is positive and one is negative, so by the theorem, there must be a point among that where it is equal to 0. So if it is equal to 0, then f of x is equal to x, therefore y is equal to x, therefore this is the correct answer. Again, over here, f of x naught is equal to f of x naught plus half, and f of 0 is equal to f of 1. So again, this is given. So I'll take again a function g of x such that f of x minus f of x plus half. So we'll find f of 0, sorry, g of 0, which is f of 0 minus f of half, and we'll find g of half, which is f of half minus f of 1. Now it's given that 0, f of 0 is equal to f of 1, so I'll just replace over here and get g of half is equal to f of half minus f of 0. So in these two cases, as you can see, this function and this function are at opposite signs. Therefore, there must be a point between 0 and half where it is equal to 0, where this g of x equal to 0, and if g of x equal to 0 means f of x is equal to f of x plus half. Therefore, second option is again correct. The set x belong to 0, 1 such that f of x is empty. Now, if we take the condition that f of x naught is equal to x naught, therefore f of x naught is equal to this is again equal to x naught, therefore f of x naught is equal to x naught. How did I write this thing? By the second option. Because the second option is correct, then only we move on to the third option, and hence this becomes the wrong answer. Again, as you can see, this is given, so I'll take what? Again, yes, you guessed it right, as g of x is equal to this minus of this. Simple. And again, we write f g of 0 is equal to g of 1. How to write 0 and 1? We should always take 0 and 1, this thing, into consideration. Over here, it is 0 and half. Therefore, I have taken g of 0 and g of half. So over here, I'll take g of 0 and g of 1. Again, they are in opposite signs. So therefore, there must be a point where this is equal, and hence, this is the correct answer. The 14th question is vector product. So we'll move on to the first option and check. So this is a binary operation star, which is given as defined as here. Sorry, yeah, as defined. Now I said u star u plus v. So we need to substitute over here u plus v. After substitution, this is already given. So I substitute u plus v, and this is what we get. This. And u cross u is nothing but a null vector. So it's null vector plus u cross v is nothing but u cross v. And u plus v with the same thing over here. This is the vector v, I think. No, this is u. Sorry, my bad. This is the vector u. This is the vector u over here. So therefore, u cross u is nothing but 0 and u cross v cross u is nothing but v cross u. So by expanding, you get u cross v plus this into this, that is u cross v cross u, and that is v cross u, which is obviously not equal to this because this term is extra term, and hence this is the wrong option. In the second case, just simply substitute over here u is equal to v and v is equal to u and check that we get the same. So this bit is correct. And in this case, well, u cross u. So if it is u cross u cross u plus u cross u cross u cross u cross u is again 0. So 0 cross anything 0, then 0 cross 0 is the same thing. So we get 0. This option is correct. The angle between the two vectors is 0. If the angle between two vectors is 90 degrees, therefore the dot product of them is 0. So I'll just do the dot product of this and this. So this is nothing but u cross v plus v cross v cross u, the bracket. So now we need to multiply them. So now see, u dot u cross v. Well, u cross v. In this case, the u dot u cross v, therefore the scalar triple product is nothing but 0 it becomes, because in this case the box product would be u cross v, and hence the scalar triple product over here is 0. Now this u multiplied by this thing, okay, u multiplied by this thing, we get the box product as u cross v cross u, the second. Now this multiplied by this, we get u cross v, and this multiplied by the last one, again v and v is there, therefore we get a 0. Now we have these two box products. So if I exchange the two terms, I have to write the negative sign, so v cross v, u cross v. So now if I change this sign, it becomes a negative, so the negative comes outside and becomes a positive, therefore u cross v, u cross v, therefore it becomes 0, therefore they're perpendicular, and therefore 90 degrees, therefore this answer is correct answer. Now it says u cross v is not equal to 0 if u and v are distinct non-zero vectors. So I've taken, as it is a non-zero vector, so I've taken v is equal to k times of u's, k is scalar. So u star v, that is u cross k into u plus k into u cross k into u plus u. Now this u and u is same, u and u is same, the box product is 0 plus 0, that's 0. And hence this option is wrong because it is equal to 0. The 15th question is again a very nice question. And Nest always has this thing that there will be only at least one option where all the 4 answers are correct. But that doesn't mean that you'll just go around clicking all the 4 answers are correct. You'll get negative marking, so don't do that. Well, n is greater than or equal to 2 and x is 1 to n. Now the sigma, capital sigma, says a small sigma is a bijection of x such that sigma of k minus k is less than or equal to 1, and that's a mod. So means it can be either 0 or 1. Yeah, and y of sigma is m belongs to k such that sigma of m is equal to m, but it doesn't say that for all m belongs to s. So this you need to pay attention. Over here it is written for all k belongs to x, and over here as you can see the third and fourth option says odd and even, so I'll just consider even, and over here is odd. So n is equal to 4. Now it says that every element must have an image such that the difference is either 0, 1 or minus 1, where it becomes a mod, right? So 1 1 0 2 2 0 0, so this can be an option, or this 1 2 2 1 can be an option, or 1 2 2 1 3 4 4, or this or this can be an option. We didn't take this condition where 1 maps to 2, 2 maps to 3, 3 maps to 4, but 4 would get back to map with 1. This makes the answer wrong, therefore this won't be considered. Okay, and n is equal to 3, the same story. Now the first option says the number of elements of sigma is 1 if y sigma is empty for some sigma belongs to capital sigma. That says that y sigma is empty. Y sigma is empty means sigma of m is not equal to m. Sigma of m is equal to m. There's none of the bijection functions have this. So in such a case, it is only this one. See, none of the options are matching, and that is it is an even number. Well, we didn't take the odd because we have this, and this. So therefore, in the even case, there's only one situation such that no element has the same image. So therefore, this option is correct. For every sigma belongs to capital sigma, sigma k is equal to k. Now, if suppose you take sigma of 1 is equal to 1, therefore sigma of 1 is equal to 1. If sigma of 1 is 2, sigma of 2 is 1. Sigma of 3 is 4, sigma of 4 is 3. Therefore, it is always the case, therefore this option is also correct. Now, n is odd implies y sigma is non-empty. See, it's odd, y sigma is non-empty, we have so many elements, so the third option is again correct. N is even implies number of elements of y sigma is even for every sigma belongs to capital sigma. So, number of elements of y sigma for every. So for every is even. So there over here, how many elements we have? We have 4. We have 2. We have 0. We have 2. We have 2. All of them are even. Like all of them are even, correct? So this option is also correct. So thank you for watching, and if you like the video, please press thank you button. Thank you button, the like button, press the subscribe button so you will not miss another updates from Exam Squad. And if you want any other subjects or papers, just do write in the comment section. And thank you. Thank you for watching.